Hi, welcome. Gosh, it's warm in here, isn't it? Why is it? It's colder. It's colder out there, isn't it, than in here? Doesn't seem fair. I'm going to take my jacket off. So, how many of you are from London or live in London? So the rest don't. Then we have good weather. Well done, the DevOps organisers, for organising the weather for us. Hi, I'm Dave. I'm here to talk about some Spring stuff that I've been working on for about a year now. You might have heard of it. So has anybody actually tried out some Spring Cloud stuff? Anybody go to Josh's talk yesterday? Okay, so we've got a mixture. What I'm going to do today is don't have much time, so I can't really cover everything in any detail. I'm going to skim through basically a really high level of what we've done so far in Spring Cloud. I can give you some indications about what's coming down the pipe, and I can give you a little demo of some stuff that we've been thinking about. I think that's the main objective. But I do respond to questions, and remember, if you have the app, there's a little Q&A section that you can use to pop up questions that I can answer if I get time to look at them. So let's get started. Anybody got any questions before I start? Cool. Okay, so this is some work that, like I said, I've been doing for about a year now, mainly with Spencer. We've got a small team of people working on this at Pivotal. Spencer Gibb joined the team, I guess, about a year ago, maybe a little bit over a year ago. He's a very smart guy who had been working with distributed systems and Netflix OSS in particular, and also some console in his previous role. And he was a little bit prophetic. So he made a proposal to Spring One, which is our spring conference every year. He made a proposal to Spring One 2 years in a row. He proposed exactly what I was doing. So the second year, we decided to try and hire him, and we did. Well, it's been very successful. A bunch of links. I'll put them up at the end as well. Actually, one that's missing is cloud.spring.io. That's a good place to dive in and start looking at this stuff. But it's all on GitHub. There's a GitHub organization called Spring Cloud. Some blogs. The slides that I'm showing today are on a website as well. I'm sure that DevOps will make them available at some point as well. Okay, so I'm going to be talking, broadly speaking, about microservices. I'll kind of wave my hands a little bit about that and describe what I think I might mean by that. It's a little bit vague, so I'm not going to try and be precise. It's just to get the domain language in place. And I'm going to then talk about what happens when you start trying to work with microservices, systems composed of microservices, which people just used to call distributed systems, but now they've got a new name. Then I'll talk about Spring Cloud and the Netflix OSS bits that we integrate with, and I'll also hopefully have time for some demos. I'll try and sprinkle those throughout the whole show, but because we have limited time, I won't be able to demonstrate absolutely everything I'm talking about. I'll put that up for my timekeeping. Right, so what is a microservice? Anybody want to disagree with anything on here? So I think the main thing is that it's when you break your app up, it's not monolithic. Runs in its own process is a good definition for me. I like that. It sort of dodges the does it do one thing question, although I did also put up there single responsibility principle. Lightweight communication is interesting, so I specifically chose the words in that bullet because people often use HTTP. That seems to be the sort of normal way of writing microservices, and a lot of what I'll show today is like that. But I also happen to think that messaging microservices ought to be a thing, and so I'm going to be pushing that a little bit. Maybe you won't have time to push that very hard today, but that's actually one of the things that's in the pipeline, some things we've been thinking about in the Spring team. But keeping it lightweight. So messaging perhaps with AMQP, synchronous communication perhaps with HTTP, what they call REST, even though it probably isn't RESTful in most cases. And the last bullet point is my favorite, actually, because I'm an old, command line Unix geek, basically. Although my first computing experience, no, I won't go into that. I've been doing Unix for too long. But I like the idea that Unix commands have their small set of things they do, and then you can compose them together. And that's what I take this to mean, right? It's the Unix way of building applications. You just find something that you can concentrate on, solve a problem, expose endpoints like standard in and standard out if you're a Unix process, and then wait for people to start building applications with your service. So a few building blocks. Spring Boot was another project I was involved in, still am involved in, which if anybody who came to Josh's talk yesterday saw a little bit about that. There's another one tomorrow. I think Josh is giving another Spring Boot talk, more of a sort of a slidey, demo-y thing rather than a hands-on workshop tomorrow specifically on boot. So you can, if you missed anything yesterday, you can get it back again tomorrow. So the basic idea with Spring Boot, or one of the ideas that's important here anyway, at least anyway, is that it's really easy to implement, stand up something that, for instance, listens for HTTP connections, which is what this thing does. This is the famous tweetable app that Rob Winch coined with a misprint. Actually, it should be, every time I give these slides, I forget. There's a quote missing from Hello World. There's a literal string. So the point that the slide is trying to make is this, by some definition, is micro. It's a small piece of code that actually runs. I can run this. I can build a jar file from it and give the jar file to my friend, and he can run it. It's a very nice model for building and deploying services, individual services. Okay, so I'm stuck within a JVM if I'm just using Spring Boot. Another thing that's interesting is once you start deploying, if you only deploy a monolithic application once every 2 years, you don't really need to be that agile about it, right? But on the other hand, if you break that up into 50 microservices and you've got 5 teams working on them, then they probably want to make changes like every day or even every hour. Certainly, no less frequently than once a week. So you need to get a bit more agile at deploying code and getting it into production and keeping it there. And the slide is about Cloud Foundry, but it's really just making the point that you need automation and you need convenient ways to script or build tool chains that let you commit code and send it to production quickly. So Cloud Foundry is a platform as a service. There are other platforms as services. They all have roughly the same idea, the same set of convenient features for taking the code that I just wrote that is a microservice and turning it into a running production system. Which leads you to the concept of continuous delivery. And this is where if you're going to do microservices, and by no means is it everybody's cup of tea, but if you are going to do it, then to extract the maximum value, you need to be moving fast. It's this theme that I was just developing about needing to, if you break stuff up, then you're going to want to change things independently from each other and push them to production at more or less arbitrary cadences. And the reason you do that is because you want to make more money, right? You put business value in these microservices and you push them and you want to be able to get that out quickly. So continuous delivery is the name of the game. There are some sort of application lifecycle features in Cloud Foundry. There are also similar features in other PaaS systems like Bluemix, for instance, or the Amazon toolchain. There's a nice book about it. I recommend the Humble and Farley book. I've always got it on my iPhone. I just sort of dip into it sometimes when I'm on the tube or whatever. Okay, so let's get into. So that was all actually about building and deploying individual services. What happens if you want to build a few of them and join them together? So here's an example. I have trouble with, this optimizing the screen size for this image. So this is a very simple distributed system. It's very common these days, right? You have a browser-based single-page application which is reading UI and so HTML and JavaScript probably from this component, which I'll call the UI server. And the UI server needs to talk to some other services to do with business data, customers, stores. The customers happen to also need to talk to stores, but not the other way around. That's the architecture of this system. So customers are people, and they have locations. Stores are also locations, but they're in the data set that I'm going to show you, they're Starbucks outlets. Okay, so this, you can sort of imagine how this works. There's also probably databases, back-end databases sitting below all this. You can sort of imagine how this works. And you can already see, I think, that this is a more complicated system to run than if it was all mashed together in the same, WAR or jar file. And the reason is because these things run in different processes, right? So the connections here, the arrows, have to know the physical address that they're going to. Okay, and that's where it gets brittle. That's the first problem of deploying microservices. And you will find that there are others. And so I've sort of summarized that by saying no man is an island. I think that was Pope or possibly Defoe. I don't know, somebody like that. No man is an island. Nobody stands on their own. In the same way, no microservice can stand on its own. It needs to be connected to other things. And so it's not enough to be able to create and deploy an app with all these nice tools. There are other problems that start to crop up. So some of them, unfortunately, are connected with laws of physics. So there's actually nothing you can do about eventual consistency, the CAP theorem, and latency. The speed of light just happens to be, a limit to speed of communication. And there are other problems with latency, of course, but that's kind of a fundamental one. But other things, like the brittleness I mentioned just now, the fact that they all have to have hard-coded, or they have to have physical addresses to contact each other, that's brittle. And being able to manage the system at runtime, being able to inspect it, see what's going on, if something goes wrong, find out what happened. Those are, as it turns out, luckily, often fairly generic and fairly boilerplate. And what Spring has often done in the past has helped you to implement boilerplate patterns. Okay, so this is the same theme, but continued to the sort of up the stack. The logical conclusion from Spring Core, sort of helping you with boilerplate in your business logic. Like you don't have to write your JDBC try catch stuff. But pushing everything out to configuration, basically. And then Spring Boot came along and said, actually, all that configuration was also boilerplate. You don't need most of it. And sitting on top of that, again, is Spring Cloud, which is to do with distributed systems and patterns, which we see people repeating. Okay, so we're not the only people who see it, right? So, and also, in common with other Spring projects, what we've done is integrate other things rather than actually write very much code ourselves. So you'll see that as I introduce the components. So here are some of the emergent features of microservice systems. So we sat down, maybe 18 months ago or something, and made a list on a whiteboard. Brian Dussault was there, he's my boss. And one or two other people, I can't actually even remember who they were. I've got some experience doing distributed systems myself in various places. I used to work on the Cloud Foundry team, in fact. Brian did a big project and delivered it successfully in EMC, a sort of IT transformation project where they basically ripped the guts out of the whole the core business systems and replaced them with some nice modular. They didn't call them microservices because it was before that term was invented, but nice modular isolated service-like processes. So we both had some experience, and these are the sort of things that we started writing down. We actually wrote a list of about 20, and the list then grew to maybe 30, and we chose a few to deliver for version 1. And largely we chose to deliver something for version 1 based on what we could find prior art, basically. We just raided the open source bank and found all the pieces that we could integrate with. And so these are the things that we found we thought were top priority, basically. So some way of distributing configuration, and by that I mean name-value pairs, right? So let's say I want to store my database credentials somewhere. It's a good idea to be able to centralize that, and also to version it so that I can roll back if there's a change, that kind of thing. Service registration and discovery is a very common pattern, so that's to do with the hard-coded URLs. So instead of referring to services as physical locations with URLs, I want to refer to them as identifiers, logical identifiers. So that's to do with a catalog of services that you can register with, and then you can consult later if you want to use it. So then you've got some routing concerns, so sending traffic, particularly HTTP traffic, in the system. I'll show you the picture again in a minute. The system that I had on the board just now had a UI at the front, and it was routing traffic from the browser basically down to the back-end services. Service-to-service calls, obviously, after you've discovered them. Load balancing takes on a new and interesting characteristic, which is that you often think about load balancing as kind of a high-level, right at the top of the stack concern, right? It's hardware. But it doesn't have to be. And actually, this is an interesting thing that Netflix did, and we copied, actually, by using their code. That you can do load balancing in the clients, right? So wherever you want to make a remote call, you don't have to go. You can still go up through the hardware load balancer and back down to the services that you want to visit. You can still do that. But there are, since you are in control of that, the call that you're making to the remote service, you can put logic in it, right? So I can characterize that, roughly speaking, as load balancing. So if there are 5 instances of the service that I want to hit available, I can choose which one I want, and I can choose it in a dumb way, like a round robin or random, or I can be more intelligent and I can say, okay, I know that I'm in London, give me the one that's closest, or give me the one that's got the least latency, those kinds of things, right? So that's a decision which is better made actually at the point where you make the call, rather than in some centralized location that knows nothing, is fairly dumb. So that's interesting. Circuit breaker is a very important pattern, and one that was described by, I don't know about first, but definitely described well by Michael Nygaard in his book, Release It, which you should read if you haven't. I can get into more detail later, but circuit breaker basically means you want to isolate. If there's a fault, you want to isolate it. You want to not propagate errors, because you've got services calling services, calling services, calling services. If one of them at the bottom of the stack fails, then they're all going to fail. It's probably better if you just stop it and don't bother trying to call a failing service. Lots of asynchronous patterns, and I'll come back to that, probably for the future, for messaging. But we do have some messaging concerns in Spring Cloud 1.0 that I won't have time to talk about, but they might be interesting, so ask me later. Okay, so the picture is a way to visualize this in the sort of the context of the whole Spring ecosystem. So if you're already using Spring, you're probably using it at least at this level. So that's like the libraries, Spring Web, Spring JDBC, Spring Data, all those things sit down here. On top of the roots, this is a tree, by the way. The roots of the tree are third-party dependencies. So everything, that's what we do well. We integrate with things so that you don't have to know so much about them. So there are lots of those. I don't know, a few hundred or something. Of course, you don't use them all. You only use the ones that you're interested in, but what you're interested in, using the right ones. And then sitting on top of the Spring Foundation is Spring Boot, which kind of adds a nice layer on top of that for consuming all the stuff below in a convenient way. And another thing we did last year was introduce this layer, which is called the Spring IO platform, which is really just a distribution of dependencies, managed dependencies. Anybody heard about the Spring IO platform? Anybody using it? A couple of people. So it's just a sort of generalization of one of the concepts, one of the features of Spring Boot, which is that you can curate these dependencies and you can make it easy to consume them, which is a good idea in general, something I wish that people had done a long time ago. And then, okay, coming out of the trunk, you've got the sort of main branches of this tree are Spring Boot going up the middle, and other things that build on Spring Boot coming up the other branches. So Spring XD is a Spring Boot application or set of Spring Boot applications for stream processing, high volume data. And Grails 3 is also a Spring Boot application. Anybody using Grails? Grails 3? Not Grails 3 yet. Okay, it's interesting because they chose to write it on top of Spring Boot. I think it's quite nice. And then the leaves in this picture are, the leaves of the tree are apps. Okay, so that's the code that you write, that's got business logic in it. And in a microservice world, those apps tend to be, services, right? They're individual processes, but they're talking to each other. So once they start talking to each other, they need this blue thing, sort of the cloud that's surrounding them. It's sort of you can think of it as a matrix joining the apps together, and that's when it's a distributed system. There are these boilerplate patterns, and Spring Cloud is providing those. Okay, so that's a visualization of everything that we've got to talk about. Here's the schematic again of that system, with some of the pieces added to the blue boxes. So the blue boxes are the same. On the left-hand side, I've added a config server, which is serving up name-value pairs, roughly speaking. So anybody who wants to can go to that. Customers, for instance, has a database connection, so it probably goes there to get its JDBC URL, for instance. Anywhere where there is service-to-service communication here, I've also got this orange stripe called load balancer. Apologies if you can't quite read it at the back. So that's the client-side load balancer, talking to stores in that case, talking to customers in that case. And also, every time it does that, feeding back to a circuit breaker monitor. So there are metrics that come out of this circuit breaker pattern. And this is why it's such an important pattern, because you can visualize it. You can look at this big dashboard. If you go to YouTube and look for Adrian Cockcroft, Netflix, you'll find there's a demo of a big dashboard with thousands of little panels on it, each of which is recording metrics for one of these interactions. And the way it works is it sorts itself so that the thing that happened, if something bad happens, it sorts itself up to the top and you can immediately see it. And they use that all the time. I'm not going to have time to demo it today. But it's there, and it's being fed metrics by these things. The other thing I've got here is the service discovery. So every time one of these apps comes up, it goes over here and registers itself and says, hi, I'm Stores, my physical address is host and port. And then customers can say, okay, I need some stores, tell me where they are. And that's how it works. Okay, so how did we implement all that stuff? We had a look around and we found some stuff that Netflix had done. And some of this is covered in Spring Cloud 1.0, some of it not. But all the stuff at the top is. So Eureka is the service discovery. Histrix and Turbine are the circuit breaker pieces. Ribbon is the load balancer. Feign is a REST client that's like you write a Java interface and it creates a REST client for you. That's quite nice. We integrate with that as well. Zool is the routing piece. It's like an intelligent routing pattern. It doesn't, on its own, doesn't do very much, so we added a few features that you can use kind of out of the box. Like the thing that we added basically is reverse proxy. So that UI component in my diagram is reverse proxying the calls to the back end, which makes writing the JavaScript for the front end much easier. So there's a lot of things actually that they use Zool for in Netflix. I'll talk about a few of them later. Archaeus they use for configuration, and they didn't open source the server side of that, so we built our own version of that, basically called Spring Config Server. But we do use the Netflix client, the Netflix configuration management bridging to Spring. Curator is for Zookeeper. Zookeeper's coming in Spring Cloud next, whatever we call the next version. And the rest. Asgard is not relevant to this talk. Okay, so those are the Netflix names. You've got Ribbon is the orange band. Histrix is the circuit breaker. Eureka is the service discovery. Zool is sitting up there, acting as a proxy. I've got the config server, which is a Spring Cloud native component. Okay, so the config server, very quickly I'm going to move through the sort of feature list and then do a demo. It has features like a pluggable backend, but we provide a choice of 2 or 3, and Git is a nice one to use because Git has, nice friendly tools that you can use to put data in and out of it and visualize it, and it also has versioning and branching and things like that. So you can pretty much automatically get the features of versioning and being able to roll back. And the way that you tend to consume that if you're a Spring Cloud client is you tend to you have a Spring Boot feature which auto-configures your app, which contacts the config server when it starts up, pulls down some name-value pairs, and puts them in the Spring environment. So that's auto-configured. That's a Spring Boot feature, but in the Spring Cloud stable, if you like. Discovery is Eureka. So it's a Netflix component. All we do is just wrap what's in there, make it consumable. I'll show you how consumable it is. Here's my first demo. Where's demo? There we go. Eureka. So this is a Spring Boot application with a single class, and it's got basically 3 lines of code, hasn't it, that mean anything. It's at enable Eureka server is the one that's actually functioning here, and also it's a discovery client itself. And the reason it's a discovery client is so that it can federate. Okay, so that's the way they use it at Netflix. They have 2 Eureka servers in each region of AWS, and then they form a sort of distributed cache. And so they have those features already. We don't have to build them. That's nice. We just basically make it easy to stand up by doing that. I could run that, but instead of running it, because it takes a little bit of time to run everything, I'm just going to show you it running somewhere else. So it's running here on Pivotal Web Services, which is our Cloud Foundry, public Cloud Foundry. So it has a little UI. It also has RESTful endpoints, roughly speaking. So you get XML in a browser. You would get JSON if you ask for JSON. So you can register yourself and consume the service catalog using sort of standard HTTP. And here you can see a bunch of services registered. So I've got the config server registered there. I've got some customers. I've got some stores. And some other stuff that isn't necessarily relevant. Actually, there's the UI as well. So those are the 3 components I showed you, the 4 including the config server. They've all registered themselves with Eureka, so that now they can talk to each other by asking for the address. Okay, so what's the next thing? Circuit breaker. Okay, so it's all about fault tolerance and isolating access to back-end services, stopping cascading failures. And the most important feature is dashboard, which, I don't know, is it worth having a look at that maybe? It's actually, let me show the code first. So all this code is in Spring Cloud Samples. It's a GitHub organization called Spring Cloud Samples. So you can look at it there. There we go. At enable Histrix dashboard, and I've got a convenience method to just map the home page to a forward, because actually when you at enable Histrix dashboard, what you do is you get some static resources in /Histrix. That's that path, and I want it to be the home page, so I've just sort of switched it onto there. This thing here is, yeah, that's just for testing. So that's basically all you need to run the dashboard, and the dashboard, when you run it, looks like this. Let's see if I can actually grab some data for it. So the customers has a stream of data in it. Let's see if that works. Yeah, there you go. Maybe. Okay, I'm not going to stress out because I didn't test this before. There would be little panels of circuit breakers on there if it was actually working and I tested it. So that's fine. Oops. There's a reference to Michael Nygaard's book, by the way. Oops. Stop it doing that. Like that. Okay. Histrix, when you're programming it in Spring, it couldn't be easier. It looks like this. So you find your methods that you want to isolate, where, for instance, this is going to do a REST template call. So this is going to the back end, and I decorate that method with @Histrix command. And optionally, I can give a fallback method that's a slightly sort of weak annotation-based feature. So the name of that fallback method has to match this method here, and the signatures have to match as well. That means if there's an exception, so what we do in Spring is we just wrap that in a proxy. So the caller gets the proxy, calls get message. If there's an exception, it falls back to get default message the first time. And then if you've got 20 failures in 5 seconds, it doesn't even bother calling the first method. It always goes straight to the fallback. So that's what a circuit is. A circuit is, there's an algorithm with parameters that you can change, but that's what the circuit breaker pattern is basically. You sort of, you kind of expect some failures, but you don't expect consistent failures, so you try to switch it off then. I tried to show you the stream. It didn't work for some reason, but there's a dashboard that you can look at. And Turbine is an aggregator. So Turbine is an app that pulls streams from all of the little services that are running and aggregates them into one, so that you can view all of their circuits in one dashboard. Which brings me to Zool. So I said Zool is a intelligent routing component. It's like a, you could think of it as a sort of JVM-based version of Apache or Nginx or something doing reverse proxy, and you can sort of tune the hell out of it. But the thing is that it's fully programmable with any JVM language, essentially. The way that we set it up in Spring Cloud, you declare a bean of type Zool filter, and then that gets added to the Zool filter chain, and you can build lots of rules like, what do they use it for at Netflix? All sorts of things. They use it for traffic limiting, for canary testing, so it's sending traffic down to new features, new apps, that kind of thing, for authentication, for security, all sorts of things. So we're just, the vanilla use case for Spring Cloud is just a reverse proxy, but it's actually a container that you can add other things to. Okay, so Netflix uses it for all of those things. I thought I'd taken that slide out for some reason. Load shedding, security, active. And that's how you enable it in Spring Cloud. You have, you wouldn't even need @controller if this wasn't a Groovy app. So this is one of those tweetable Groovy apps, like the first example I showed you. If it was a Java app, you wouldn't need @controller. It would just be @enable Zool proxy. So that's a specific set of filters that we added if it's a Zool proxy. You can also use it, interestingly, there's another thing we're going to be developing actually in the next couple of months. There is a Sidecar already. So if you @enable Sidecar, you'll be running this thing in a standalone process, and it has all the knowledge of circuit breakers and proxies and Zool filters and service discovery and load balancing and all of the stuff that we do in the the bottom layer of those stores and customers apps. but it's not in your process, it's a process that's in a sidecar. Why would you do that? Because your process might be not written in Spring, or not written in Java even. It might be a .NET process, or it might be Python or Ruby or whatever. So you've got a sort of polyglot, and you make these features available to other languages and other frameworks by providing a sidecar. That's a very common pattern. It's one that they do at Netflix as well. So the last thing I want to talk about, and hopefully give a little demo, is I want to tell you this story, right? So as a microservice developer, this is something I've been thinking about for a good long time. This is what I want. I want to write my code, and I want to run it on my laptop, but I still want to be able to have some confidence that when I deploy it in the system, it's going to work. Does that sound like a good plan? So here are 3 ideas about how you might approach that. Okay, so one that we've come across that we will be investigating and probably integrating is Stubbing. And so I give a shout out here. Is there anybody here from for Finance? Okay, so there's a company in Poland called For Finance, which has a GitHub repository that you can visit. It's got a load of stuff in it called Spring Micro, I think it's called. And they started work on that roughly the same time as Spring Boot. And then they came to us about 6 months ago and said, look, we don't want to maintain our own stuff. Why don't we just merge some of it with yours? And so they started sending us pull requests. And we haven't got one on this yet, but this is one of their main features. So at For Finance, if you want to write a microservice, what you have to do is define its contract. And when you define its contract, that means you build a stub and a set of tests that assert that the behavior of your actual service is the same as your stub. So if you can picture that. And then you publish those stubs as a library that people share, and then people can, as a developer, I can just grab your stub library if I want to see how my service is going to interact with your service. That's the basic idea. And they have a lot of plugins and APIs and stuff around it, so that's quite interesting. Another thing you can imagine doing is actually taking the code and actually, instead of running it locally, actually running it in the real system, running it remotely. I could push my application up to Cloud Foundry, for instance, in the system I was just showing you, and then debug it remotely. Okay, everybody knows that's possible. Who likes that experience? It's okay, but it does tend to be a little bit slow. So I think it should be a possibility, and you can actually do it using this feature that was just released, actually, with Spring Boot 1.3. There was a milestone last week. Phil Webb did a blog about it, so if you go to spring.io/blog, it'll be one of the top on the list. You can learn how that works. Essentially, what he did was he built a special class loader so that when a Spring Boot app starts, it puts an extra class loader layer in, and then at the same time it starts listening on a special HTTP endpoint. And then in your IDE locally, if you make a change to a file, it sends a message to that endpoint, and what the message contains is all the things that changed on your local disk, right? So it can communicate the changes, and the class loader can drop everything and rebuild itself. And that actually seems to work, and you can definitely do remote debugging into Cloud Foundry and other fairly opaque systems, so it's promising. And the other idea I'd like to propose, since we have this service catalog, right, Eureka is sitting there. I'll remind you. Oops. There it is. So what if one of these, so these things here, these green things are links. I don't know if you can tell. Actually, the people in the front row are probably the only ones who can actually tell, but those are links to the physical address of the service that's been registered. So what if one of these was actually my app running locally? Okay, so if I run my app in the IDE, let me do it and see if it works. So here's my customer's app. I'll close down some of this stuff to reduce the clutter. So here's customer app. It's a Spring Boot app. It has @enable discovery client. So I know that if I debug it as a Java application, it's going to run locally, right? And by the time it finishes, I think it's finished, there we go, it's running on port 9000. It probably has by now registered with Eureka, but just to get the demo right, what I'm going to do is, you probably can't see that at the back, can you? So I'm going to, whoops, help the people at the back. I'm not going to help the people at the back by doing that. I'm going to help the people at the back by doing, I thought I had that feature switched on, but I didn't, by doing this. I'm just going to curl that system on localhost, just so you know it exists, right? So I've got customers, there's a customer's endpoint. It's a Spring Data REST application, so I can just use it to create customers and to interact with the customers. And I know that I've got here somewhere, REST customers, no, customers. Oh no, not that one. So I wanted that one. So customers has a test file with a customer JSON in it. So what I'm going to do with that is curl it into localhost, just to make it easy to actually debug something meaningful in the system. Customers, I'm going to use a special alias of curl that I've got set up to do JSON, and I'm going to show you the result. Then we need to do -d at that thing. Okay, so that's going to send that file. Can everybody see that? It's going to send that file into the local service, and I got 201, so it means it worked. Do it again, so I've got 2. And then if I went back to the original, /customers, follow the link with a get. There we go. I've got customers, right? Nothing happened. Not debugging it yet, right? I'm going to set a breakpoint. Set a breakpoint here. So this is in a component where it's talking to the stores, called stores, a store integration. And the way this works is I've got a load balancer, and I'm going to choose an instance of stores, and then make sure it's okay before I start using it. Okay, so this is kind of manual use of the service discovery a little bit, but you get the picture. So there's a breakpoint. So hopefully if I do that, see, so I'm doing a get locally of that resource. It stopped in my breakpoint. All right, so that's fine. I expected that twice. Fine, I expected that too, because there are 2 customers. But actually it came back anyway, right? That's the circuit breaker kicking in. That's the fallback, actually. So there was a timeout. It failed. It went to get some data from somewhere else. So that's the basic feature, but I haven't shown you the Eureka thing yet, have I? So that what would be cool would be if I could refresh that, see if it's there. Okay, so I've got another customers, which means that if I went to customers UI, okay, customers UI, you see that? Okay, so customers UI just came up with some data, but it triggered my local breakpoint. Did you see that? Right, so I'm running this service locally, but my cloud service has used the Eureka catalog to look it up and come back to me through a proxy, actually. So there's a proxy sitting in the middle where the remote services can get to mine, and they've triggered a breakpoint. And so I can have a look at what's going on in here. I can say, okay, services, let's have a look at this instance. Has it got the data I expect it to do? It's got the service ID, correct? It's got a host for me, so I think it's working. Okay, so I'm happy that I've debugged it properly. And there's my second breakpoint. And it's all working. So that's actually as much as I was going to show. I'm happy to take questions. I'm also happy to put the links up while I do that. Let me check if I've got any questions on the app. I don't know if it refreshes itself. I have 0 questions. Oh, I do. Okay. How does Spring Micro compare to other contract-driven development frameworks, Pact and ThoughtWorks versions? I don't know because I don't know enough about it. They just contacted us and said they wanted to send us some code, so we said yes. I think it's going to be a lot more lightweight, but Pact is probably a good place to start if you wanted to think about the way that it works. Yeah, I agree. So those are going to be alternatives to the same problem. Anybody got any other questions? Yes?
So you've got circuit breakers in the applications that don't include using JDK proxies or something like that. How do you test their working? Do you have, how do you automate that?
How do you automate testing of circuit breakers? Well, I mean, they're highly configurable, so one thing you can do is write a test, and in the integration test, you just pin the circuit open. Or so you can basically change the state of the little state machine that's keeping track of it in the test case. So that's for kind of low-level testing. That's what you do. So does that answer the question? Yeah. Anybody got any other questions? Yep.
With Spring Cloud config, I know you've got support for Git repos. Is there like support to read the properties files itself?
Okay, so with config server we have support for Git. Is there support for reading local files? I think is what you're saying. Yeah, yeah. So those are the 3 choices: Git, Subversion, and local files. Local files can't be versioned, right? So you can only have the most recent version, but it works. It's probably not the greatest HA solution either. So unless you've got shared file systems, so probably Git is better. But to get it, to test it and verify that it works, it's a good choice. Actually, it's just as easy to have a Git repository which is local, because you can just point to a file URL with Git, and it treats it as a local resource. So you can do that for testing as well. Any more?
What if you change your configuration at runtime?
What happens if you want to change your configuration at runtime? That's a very good question. I've only got two minutes, so I'm not going to try and demo it. But we have a couple of features. So one is I can show you, since this process is working, I can show you it doing something. There's a refresh endpoint which I can post to, and it came back with an empty array because it didn't find any changes. But that does a couple of things. So one thing it does is, I don't know how much you know about Spring Boot, but there's this @configuration properties feature, which is for binding configuration to Java objects. So the first thing that does is just rebind all of the configuration properties, which is actually pretty useful if you're using those. If you're able to use those beans at runtime, then you get that straight away. It also changes the log levels if you wanted to send in a log level change. And the other thing we have is called, so that works for a lot of use cases, but it doesn't work for everything. We've got something called, let's see if I can find an example of it. Got something called refresh scope, which basically adds up to more proxies in Spring terms. The integration test, that's probably enough to show you what's going on. Let me show you this. So there's a, that's not a very good example actually, because it's just testing something that doesn't work. Yeah, must be a better one than that. Refresh scope integration test, let's look at that one. There we go. Okay, so we've got some @configuration with beans that are in @refresh scope. It's a Spring scope, and the basic idea is, so like other scopes, what you get if you consume that bean is a proxy for test properties, which is lazy initialized. And when we get that refresh event from the refresh endpoint, we just clear the cache, basically. So next time somebody calls that a method on test properties, in this case, is going to go through the Spring lifecycle and recreate it. And the value of that is it's sort of atomic in the sense that Spring knows about all the dependencies of these things, and if any of them are refresh scope, then it creates them all at the same time, right? So the first time you consume a method from a refresh scope bean, you're getting all the Spring lifecycle. So that's, is there any other feature? Well, there's another feature which is interesting, which I mentioned briefly at the beginning about messaging. So if you're paying attention, you probably realize that sending a post to a single HTTP endpoint isn't a great way to run this. If your service is running like several physical instances, what you want to do is send the same message to all of them. And you don't want to have to sit there hitting refresh. So we have an AMQP-based bus that you can use to send the same refresh message to all of the instances of a service, or all of the services. So those are a couple of features. I'm probably missing something, but that's the first response, at least anyway. Come and ask me afterwards. Well, I'll try and remember everything else. Anybody else? I think we're bang on time, so. Is there some authentication support he's asking about? Okay, yeah, so there is a Spring Cloud security module that I haven't mentioned. Some of the features in Spring Cloud Security are now in Spring Boot 1.3, so there's a bit of an overlap there. Those features are at enable OAuth 2 SSO, so you can do OAuth 2 single sign-on basically with an annotation. That's nice, an annotation and a bit of configuration. There's that, and then in Spring Cloud itself, which will stay in Spring Cloud, we've got authentication through the proxy, so that if you can configure the proxy basically to send tokens or cookies or authentication headers, basic authentication headers to various different services, depending on which ones need which things. So that's the security feature. There's room for more there, definitely, but that's the first. That's version 1. Yeah, I think we could probably wrap it up there, actually, unless somebody's got a burning question. Come talk to me afterwards. Thanks.